Hey guys, how's it going? So today we're gonna be going through this project that I'll be walking you through. So the project is essentially making predictions if a specific crime type will occur within 5 miles radius from the current user's location. So this is quite a heavy project, all the way from data engineering, ML ops, backend systems, mobile apps, and we're gonna cover all of this stuff. And I'm gonna be walking you through the code so that I get to explain what's actually going on. So before we get started, I thought it would be a good idea for me to kind of show you the predictions of the app and how we were able to get 90% of accuracy. We trained this system with over 25 million data crimes dating all the way back from 2017. And we're going to get into how we're able to get the data because of you currently cannot get the data from the government. So we're going to talk about web crawlers and distributed web crawlers and all of that so that you get to understand. I'm just gonna register so that I can be able to show you guys how this app actually work. So I'm just gonna say at gmail um, dot com. Then I'm just gonna punch a simple password so that you guys can actually get to see like so. So location is quite important. So if I try to sign in, the app will tell me that a home address is important. So this is because if you currently not enabling your application, we can be able to use your home address. So here it's gonna be a pimple location. So we're just gonna use Soweto Pimple. Sign up, and this is where we are. So I'm just gonna deny, but you can actually say yes, allow the app to use the current location, but let's just deny. Then it's gonna use your home address. So you see it's just saying Pinville. As we can see that the app actually predicts crime at Maponya Mall shop 102. So this is the number of crimes that will occur. We can see that there's going to be 42 crimes that are predicted, and the crime is actually high. And some of you might be quite curious, is like, is this actually true? And if we take a closer look at Twitter, I just searched for pinfall crimes, and this is actually true. We can see what the general population is saying, and we can see the date here that this is just 3 days ago. I just sorted by latest. So if you can do, or you can go to Twitter and search for specific location, you can see that it's really people actually tweet about high crime in a sense. So we can see that crime in Soweto and specific location is quite high. But what makes the app so different from people who just say crime in this place is high? What makes the app? What gives the app that value? Why should someone use this app? So the app first and foremost, it predicts crime within the next 3 hours or so, right? So what it does is that it also predict crime within 5 miles radius. So it tells you that within your close location there will be crime, there will be an assault, something like that, and there will be a murder, and this is the predicted number of murder that will likely occur. Okay, so why did I do that? It's because of I wanted to give people some sort of like actionable intelligence. So imagine if someone just told you that, just waiting for this map to load. Imagine if someone told you that, okay, at Hillbrow today, there's gonna be a crime. Like, it's very huge. You don't know where to search. You don't know where, at which corner or something like that, this crime will occur. But if we really try to go deep all the way, we narrow down the search, right? The problem becomes much harder, but it becomes much more valuable because I can say if you are currently at End Street, there was likely to be a car hijacking that will be taking place in the next hour. We predicted that. We know based on the historical data that there will be a car hijacking, and this is the probability of this. Okay, so we're gonna go over through all of this, and I'm gonna cover the whole entire architecture and how the app works in much more detail because we also predict density. We also have the map on the app whereby the user can see the density of this crime. So we're using neural networks to predict these. So unfortunately, crime density is not available for this service because it is quite expensive to kind of like serve deep learning models. So it's reserved for specific locations whereby crime is extremely high. So, what motivated me? What made me actually build this app? So, if we can look at crime rates, South Africa is actually number three in the world when it crime to crime. So, this is what led me to build this application because of now crime in South Africa is really getting out of hand. We can see that the number of kidnapping is just growing a lot. So, and this is 2023 stats, right? So by the World Population Review. So crime in South Africa is widely hard. And the second thing that motivated me is that I like hard problems. So I've went through some of the articles and some of the professors in South Africa have attempted to solve this problem, but unfortunately they were not successful because of data is not available. So that's why I'm gonna go all out on data engineering, cover that, and show you guys how I was able to kind of like get over 25 million data points. And that's where I think also the value will be because of without data you can't predict where the crime is gonna go into. We're gonna cover some of the research papers that inspired me to kind of like be innovative with my predictions, and we're gonna get into all of that. Okay, so how will this talk then go? So the first thing that we're gonna do is that we're gonna be talking about data extractions. We're gonna talk about data engineering, all the way from the data cleaning and trying to actually shape this data in much more of a tabular data because we're working with unstructured data set. We're going to talk about MLOps. We're going to talk about things such as feature store, orchestrating our model building, as well as automating some of the model deployment stuff. We're going to talk about backend. I'm going to cover things like Docker, Kubernetes, and I'm going to show you the code and why working with virtual machines it's quite important. I'm going to give you some sort of like an example why what is it, DevOps is so important, especially when you see me doing things manually. Then when we start to automating these things, then you will start to appreciate why DevOps is important. The mobile app, I'm not a mobile developer. I don't know much, but I use Flutter by following some tutorials over the internet. So I'll just leave my 2 cents, but I wouldn't say trusted because I'm not a mobile developer by any means. So without wasting any time, let's get into the code and the architecture and see what actually went down. So these are my data source. So one of the data source was Facebook. We use all the news sites in South Africa, including EWN, and some of the Kawa War sites. Then also Twitter was one of the main data source, quite very important. I have to say that I know that some of you will probably go hard on me on data privacy and data policies and all of that, and which is quite important. I have to agree, and I leveraged APIs from some of these social media sites like Facebook. It does not allow bots, so it's quite important to be responsible, and I do know that. But anyway, we have profile, so we collect data from like specific profiles like on Twitter, because there are specific profiles which we're gonna look into that post about crimes in South Africa, and I just need to pass the name of that profile. Then I also have keyword search. So here the idea is that I just pass the keywords. I can say something like car hijacking Tembisa, then it's just gonna give me all the tweets or posts that are related to that. So we're gonna get into how we actually distribute all of this stuff. So we have also news articles that we kind of like extract. We're gonna look in some of this code as we go through the architecture. So what's going on with the architecture? How do we then make this thing to be fast, right? So what we have here is the seed URL, which I've stored in NoSQL and MongoDB. So the idea is that we needed some of the news sites URL, because of we know that we have to go through the pages on those sites, and we extract those articles that are related to crime, and we going to be processing them. But because if we want to distribute this and then do it across multiple nodes or processes, we leveraging Celery as our distributed task queue, and we're using Redis as the broker. So it's actually easy to actually set up these two components, and it's not that much of a headache. Um, but the idea is that we have these tasks that are within this broker Redis, and then each worker can actually extract these tasks. So we can think of a task as something that is going to crawl aside and get a HTML file, and we're going to extract the content from that HTML, right? It's called HTML parser. Then, after we've extracted this data, we don't do any of the data cleaning and all of that. We just gonna pass it into our some sort of like a data lake. In this case, Cassandra and S3. So we pass in this data as raw data. So this is gonna be more like our reference source, right? And I have some deduplication stuff that these workers can access when they get the URL from the broker, because now this broker has queued them, so the workers consistently have to check if there's any task that they have to process. What we have is that I have this deduplication service that I build. The idea is that each worker can check if this URL it is being processed, right? We don't want to duplicate the work, because it's possible that you can actually process multiple URLs, right? So to avoid that, we check if like this URL has been processed. You can use Bloom filter, which is a probabilistic hash map that you can actually be able to check if this URL has been processed. But I personally used Redis. I find it to be much simple and much more scalable in a way. But like I said, you can use Bloom filter. um, I know some of you probably might go hard on me and say why we need reasons. Honestly, I'll probably write a blog and explain some of the decision thinking that I did. But anyway, um, I tried. The first thing that I did was I tried to use article IDs and tweet IDs. This solution was probably not scalable. So by tweet ID, like if you go to Twitter, like on the URL, you get like that ID of the post. Then I was trying to use that to kind of like say, okay, I'm gonna store this in the Redis, but this I saw that it was not. The ID was not going to be scalable, and because of you have to cater for each site, you have to cater for Facebook. Also the URL just worked fine. You know that URL will be different for everything, so that one I feel like it worked fine. I'm a deep learning researcher, by the way, so most of the time when we build, we collect data, we try to hash the articles, and so the different techniques that we tend to use, it depends on different scenarios. Okay, so yeah. um so yeah, like I said, that the most important thing, especially in South Africa, we have the Bopia Act. So it's very important that we kind of like follow the regulations with how we collect data. Check robot.txt. Also check if like the site does allow you to kind of like collect the data. This is very important because if they do allow you, then just be responsible and don't like just go hard on the site, because you will take it down. Just have like stopping stuff on the application, like stop the processes maybe for 2 seconds or something like that. I think that is quite important as well. um, yeah, so some of you might be, why didn't you use like multi-trading? And this is because of race conditions. So I was trying to avoid the race condition problem. I did use it. I did use the threads, I think, but it was a simple use case, because this I think it was the multi news. Yeah, I did use threads because this was a very simple use case whereby there was this news site that you can collect articles, and then the articles are grouped by the location. I just needed to make sure that I have this log so that I don't corrupt the data that I'm writing to. So this is where I use multi-trading, and it still works fine. But the problem might be the Python GLI, so the global interpreter lock. So only one Python thread can execute your code at the time. So that's the bottleneck of also multi-threading, and when you try to use multiple threads in Python. So unlike if you were using something like Rust. So another thing that made me choose this architecture was the fact that workers can be scaled horizontally, right? So you can have multiple nodes running this. So that's one thing that made me choose this architecture that we have right here. So before we move from this data extraction, how does the data looks like, right? So this is an example of the data that we have. Um, so all of this data is stored in our data lake. So I just brought this data up so that I can be able to show you an example of how the data looks like. So we can see that we have an article. This is a title. So a man dies of being shot. Then we know we have the date of the article. So we also have the article itself, right? And you can already see a problem with this if like you really, because if we want to train a tabular data and we want to create features from this, even if we're going to train deep neural network, we don't want a text like this. So we have a lot of work to do because we need to extract the date from this article, as well as extract things such as the time the crime took place, right? So you can see that the man arrested for kidnapping. This is the time of the article, and we're gonna need to find the time of this crime event. We're gonna need to find the time, the date, all of that information, and we're gonna need to know what type of crime was this. This was kidnapping and it was rape. So we need a way to classify this article. So we have a lot of work, and now that's what we're gonna go into. We're gonna go into the data engineering and explain how we solve this problem. We said that we stored all the data that we extracted, whether it's from Twitter, all the news article, we stored all of that data in our data lake. So now we need to extract that data, and we saw that it was a more like a JSON, and some of the files were CSV format. So we need to pretty much um, uh, extract some of the features from that text. So one way we can think about, we can do what we call name entity recognition. So whereby we actually extract locations from a paragraph, we can train a model to do that. But as a like I said, I'm quite an expert in this AI research and engineering stuff. So I tried this and I knew that it wouldn't work because of the bias problem. So by bias, I mean some of these models that are out there. Uh, so they have been pre-trained on data that is not from Africa. Like for example, let's say the word Soweto, the model can actually identify that as a person name because these models have been trained on like some of the data probably from other countries. So there is a little bit of bias. So what I needed to do essentially was to fine tune an open source model. But before I do that, I needed some sort of like a seed data set. So this is what we call instruction fine tuning. Before I talk about this, I just want to say that, like I said, that this is what I do for a living. So I cover research papers and open source code. So if you're interested in AI research and engineering, check out my second channel called Challenges Space Shuttle. Um, so yeah, we pretty much cover like the research stuff, right? So you can see here llama adapter fine-tuning method. We cover the code, we write pseudocodes and all of the stuff. You're gonna find them inside here. So pretty cool stuff, right? So we cover like transformers. So Sorry to get you out of the topic, but I thought it will be good for me to explain to you. So where we were, I think we were here. So anyway, so the idea behind instruction fine tuning is that I needed to create some sort of like input and output. But because of I didn't want to do that manually, like whereby I have to go through articles and really try to extract the name, the places from article, that will be way too expensive. Remember that we have 25 million articles and posts. It will be very bad because now you have to read each article and do that. So we can actually use Chat GPT to do that. So it's quite expensive to use Chat GPT API. So I personally used it to generate 10,000 examples. Like I said, that what I did was to fine tune, which we're gonna explain in a second. But the idea is that you essentially pass the model the prompt, and you give it the tweets. So you give it an instruction, you give it an input and output, and it's gonna go through the tweets, and it's gonna say, okay, crime, yes, this is a crime, this is a protest, this happened at Vets University. It's gonna tell you the date. This is amazing. Can you see this? So this is what you're looking for. So now you don't have to work with that junk of JSON and paragraphs and all of that. So this is beautiful, right? Um, so that's what I did. But like I said, this if you're gonna do this for 25 million stuff, it's gonna be expensive. So we need a better technique because of like I said that I do this for a living or AI stuff. I know how to fine tune some of these open source model. I think we were here. So this was my prompt to when I was using the OpenAI API to give it this prompt. The instruction as well as give it how it should return the output. I wanted the output to be a JSON, and after I've collected 10,000 examples, I then fine tune an open source model produced by Facebook, which was the Llama model, and then I was able to actually get a good model. Then I used that model to generate the output for like the rest of the data points, which was quite much more efficient because of I was using PERFT method, which is the parameter efficient fine tuning techniques such as LoRa and QLoRa. So, like I said, if you're interested in this stuff, just watch my second channel. It's quite interesting AI stuff. But yeah, it's just for efficiency because of these models are quite heavy. So imagine having something that is quite it takes something like 4 gig of your memory, so you kind of like have to reduce that. So we use these techniques, right? So yeah, so but the problem with this is that these models, even though I did fine tune them, they're still not deterministic, including OpenAI models. So including even BAT, so they are not deterministic. Sometimes you can tell them and they will return a code. Sometimes they will return a text. So you have to then handle these cases whereby the model does not return what you actually want. So it happens. Yeah, so it is just the models are not deterministic at some point, so which is fine. But what we needed to do then is to write an algorithm that is going to filter the crime because of the crime classify the articles. I don't know if you saw that, just to remind you. So we can see that it classified that, okay, this is yes, and this is at some point you're going to see none. So what we needed to do is to filter by that, right? Secondly, um, we needed the models, like I said, they're not consistent, so you needed to write an algorithm that will be able to detect if this is a JSON and it contains the results that we want. And that's why I wrote this not a good looking code. And please bear with me, I know that this is not a good code at all, but I needed to do this because of these different ways the model can output results. So you can imagine I needed to kind of like come up with my own algorithm and write regular expressions. I know this code is not readable by any means, so it's not something that I'll like someone to read because of I'm the only one who can understand because of our it was based on trial and error. I was looking at the output and trying to come up with an general algorithm that can actually be able to um, detect that okay, this output from an AI is actually correct. Okay, so that's what I did. But yeah, that's that. Yeah, so spoke about the algorithm stuff, but now the good thing is that we able to generate the training data set. So the training data set, just to show you, so this is what we have. Look at this. So like I said, I'm using this is not my production data or production code. I will show you the production code. This is based on experimentation that I did. I don't use notebooks in productions or anything like that. So this is just to show you as I'm explaining. That's why I needed to create this stuff. But anyway, look at this data. It looks beautiful after all the hard work that we did. So we have moved from this junk to this, right? Now we see that we have like latitude. All of these transformations have been done. We have rainfall populations, which are, we're going to get into feature stores and how this is created. We have the dates, we have the crime categories, we have all of the stuff. So the data now looks much better for us to train this. We can even train deep learning models, which we're gonna cover as we go through. But that's what I had to say. Let me check if we covered all we had to say. So, okay, this is something that I want to cover as well. Is to say that feature engineering is quite important. So like I said, I was inspired by jog paper. I think these guys have showed some sort of like a correlation between the weather and crime. So I knew that I needed to get a weather data and try to see if it can help me predict these crime better. So that's why I have weather data in the final data set, like rainfall and all of this stuff. I have also this holiday data. So I needed to create my own class for holiday data. This is purely because of the I think it is what is it? I forgot which holiday is it. Let's just look into, no, not that code, not the backend, the model saving, and we gonna go into sorry about this, guys. I just wanna make sure that I'm able to show you this class. Yeah, this is the class that I'm talking about. So essentially Good Friday and Family Day. So it depends. This can be a holiday. It also depends on whether this was on Friday, if I'm not mistaken. So I had to write this logic to handle that case, right? So that's why I needed to create my own class that I can actually be able to use to generate South African holiday. Given any year, this thing is so dynamic, so it does not rely on a year. So any year, it just works as fine. So that's why I needed to create that. But I was inspired by Facebook. So Facebook, what it does is that it groups their features. So we can think of like there are certain features that they call probably like derived features. For example, average number of X crimes on Monday, or maybe like number of crimes for the past 3 hours. And then they will have another features for the user, maybe like or something like that, or maybe they will have in this case I can create features for like for the crime type, right? Okay, or maybe the location, that okay, so way two is a township, so way two has this number of population or something like that, right? So that's something that we can do. I've done it to some extent, but I didn't overdo it. Like Facebook has something like thousands and thousands of features that they use in production, and what they do, Facebook, is that they recurse through the graph, because of that's how they store the users and the data, like, right? It's a graph. So they have to regress through that graph and get all these features during the saving of the model, which is quite expensive. And they have resources to do that, but in this case for me, I didn't think that will be a good idea for me to kind of like have 1000 features, because of I don't have necessary enough resources to serve my model. It would be nice to create as many features, but that I was not something that I was planning to do, because I was thinking also of saving these models. I have to hit 30 milliseconds of latency in production. So that was the target. So I didn't necessarily use many features, but I want to talk about how I use data augmentation in order to increase my accuracy. So we gonna look into data augmentation, which is why I believe that might be one of the reasons why the model is doing so well in production. So looking into data augmentation, so augmentation is something that we tend to apply it in computer vision, but it can actually work well also in some domains such as NLP or working on tabular data. For instance, we can see the time whereby crime tend to occur looking at this table on the screen. I'm just going to zoom in so that you can see. So this is knowledge, right? This is factual knowledge. So we can use this in order we can be able to sample data so that we can know that okay at this time, especially Saturday, crimes are extremely high, right? Like um, so the midnight Saturday, so its crime is way too high compared to probably Thursday around 3 a.m. So the crime is less compared to Saturday. So this is knowledge that we can actually use so that we can create probably 1% of data set, 1% to a data set coming from data augmentation, right? So how I did that was that I generally took that image and I created a data frame. Then what I did was that I sampled hours so that I can create my augmented data, my artificial data, so to speak. So what I did was that I will compute the weight based on this image that we looked into. So we have these total count. So you're gonna compute the frequency. Then this is going to be your weight hours. Then you're going to have the hours. Then you randomly sample an hour given these weights here. Then this is going to return a sampled hour. So the idea is that we simulate the same distribution from this here, because this is fact, right? We can see that this is factual information, so we have to pretty much follow the same distribution as given in this image. So that's what I did. And not only that, I think I did it for also for sampling the dates, because we had more information, and this was quite important, because what it meant is that I needed to weigh holidays, because of we saw also the patterns that holiday tend to be where crimes tend to be high. So we had weights as like this. And the reason I hard coded these things is because of this information. It's coming from this image that we just observed. So I had to kind of like calculate the frequencies and all of that, like so. And another information that I used was this, right? So this is very valuable information. This is coming from the government, South African police force, but it's not necessarily crime events. So this is more like statistics that okay, within this month, these are the number of crimes. So this is not necessarily useful from like predicting crime, but it is useful to weigh like specific locations. So for instance, if I go to Gauteng and I look into specific places like Albertine, I can see there are crimes, and this will weigh this location based on this crime statistics. So it's quite also a useful data that you can use to create features. So which is something that I did. So but yeah, that's data augmentation, and it's quite powerful technique that you can use. And I was just showing you how I sampled from this and how I kind of like simulated the distribution. I hope that gives you some idea how I did this. Okay, so let's look into the MLOps stuff. Feature store, right? Um, so just to kind of like give you the reason why we need feature store, you can think of this as like usually data scientists, when they work on their own, like even within a specific organization, they can create their own features. For example, someone can say, okay, I want to create a feature about average crime that took place on Monday for a specific category. And then after that, they can actually store that feature inside some sort of like a database, right? So during training, it's okay for you to store these features in something like S3 or Data Lake. This is mainly because of we're not that curious or like about latency compared to in production, whereby you might want to use your feature store to be redis, which I'll get into. But in training we care more about throughput. So that's why I'm saying that as long as you can store you can persist your features in a specific like centralized storage, that's fine. Everyone can access these features. So that's what I did. So all the data that we spoke about now, like all these population, rainfall, all these are features, so we can store them there. And this will give you a better intuition if you didn't know feature store, because what when we get to the models, you'll see that actually we reuse these features as we train different models. So this is good. So a lot of people don't have to like recompute all of this stuff like all again. So you can just get them from this store. So it's a very, very great concept to know if you are an MLOps guy or a machine learning engineer. Anyway, so the next step, what I do is to consolidate all of these features. So I need all of this data so that I can be able to kind of like create my training data set, right? But this is where we face like Hulk. We face like a very giant problem. So what's going to happen is that because we're working with unstructured data, how do you then consolidate? How do you bring this data together? Right, because of we don't have IDs. This is not a problem whereby you have like a table and there's like these rows and there each row has an ID or something like that. That does not work. So you have like latitude, and you have a table about like coordinates, and you have a table about like the location. You want to join these two, so you have to do something. Um, right? So one way we can use we can go back to computer science algorithms, because of what I needed to do is that I needed to join some of the data based on latitude and longitude, and I'll explain why I use that, because I know if some of the software engineers, they might go hard on me or there, but I'll explain in a second. So there are certain algorithms in computer science like bolt tree, KD tree. If you don't know these stuff, I'm planning to write them from scratch using Rust. So subscribe to the channel. I'll be writing these algorithms from scratch, including sorting algorithms. So you will have a better context what they do. But the idea is that they are much more efficient when you have like coordinates, and you have like a range of other coordinates that you wanna uh, kind of like check for their similarity and get the closest ones. They can do that much more efficient for you. Okay. So that's what I did, but I didn't use these algorithms. I found them to be quite slow. I don't know if it was my code or what happened there, but I'm just gonna show you the code that I wrote. I had to pretty much write my own code. There was the time whereby I wrote a code that took 40 minutes. I was like, no way I can write this. And I think I used also the CD3 algorithm, and it was also somewhere around those lines. And this code that I wrote here, it takes seconds. I repeat, guys, seconds. Like literally, this is like maybe less than 10 seconds. And like we're talking about millions of rows here. So this was quite impressive. And I'll tell you the secret. The secret is to avoid double for loops and have constant lookups. So it's very, very important to understand data structures and algorithms and their time complexity. Sometimes when you see your code like really, really going long, go through it line by line, understand what's actually going on. When you calculate the distance, and try to kind of like understand, because of you can be IO bounded or something like that, so you need to understand what's actually going on with your code and memory, all of the stuff. So I covered data structures and algorithm in my YouTube channel, the one that I'm talking now on. So you can check them out, but I'm gonna cover this stuff like this joint set, which is another brilliant algorithms that I will actually cover in much more detail. But this algorithm, this code that I wrote myself is much more faster. So there's another thing that I used. I didn't write this one. It's a library. It's a C++ library. I used the C++ one than the Python because this one it approximates the similarity search between the text. So let's say you want to join like Tembisa, and then you have like text of strings, like because if you don't have ID, so you want to like get the similarity text, this the most similar text, so you can use this algorithm. So I'm also gonna code this up since I'm going all out on Rust. So you guys will understand how they work in the background. But yeah, that's that. So that's important because now I needed to join all of the stuff, right? That's why I needed to kind of like write these algorithms. Um, for me to kind of like join my data set. So you can imagine that I have like a row and I want like some sort of like population and area. That's a feature, right? And population and area has like some sort of like latitude and longitude. So I need to join this stuff. I think I want you to really understand this. So for you to understand this, I would like to show you an example. For example, you see this is like a feature, something like that. This is Alexander, then this is more like a population and area, then this is the coordinates. So we want to join this with another data set, but you have the coordinates. Because you can see we don't have IDs, and we have to use these algorithms. I hope now it makes sense and it gives you a better perspective. So that's why I said we have these feature stores, and all of we need to join them. Anyway, now that you have that in mind, we come into model building. So here is whereby we have different crime models, specializing in different different categories. Like for example, we have a model that predict crime. We have a model um, that predict crime frequency. We have a model that predict crime density. So all of the stuff, and this model does that, and I'm gonna show you how they work in a second. I trained these two using the LGBM base because of it was quite accurate. Like I said, we using this ML flow experiment tracking, so it tracks the experiment that we do, and it kind of like choose the best model that we should be deploying. So and also like I'll say like I'm planning to write an algorithm or maybe some sort of like a code that check also the memory, and because of sometimes like you can get like 1% more accuracy, but that model might be expensive to run in production. So it's very important to check also like the memory, how long does it take the memory, which I'll show you. I did that, and I wrote also the metric, the logging of the metric code. I'll show you how it works, but I'm just saying that it's quite important. Anyway, the cramp density, I'm using neural networks um, to predict some of the coordinates where the crime will take place. So within, like I said, within like 5 miles radius, and so it's quite pretty cool. Yeah, the challenges is that you need to construct the data set for these problems. So these problems, because of their target will be different, so you need to like be able to create that. So you need to write the code to do that. So yeah, and after we've trained the model, like I said, we have these experimentations. Then the model goes into S3 or using Digital Ocean, which I'll show you in a second. So then the model will be able to, the system will be able to know um, which model that we kind of like pushed to the register should be in production, right? So you can see this is quite simple. Is the training process from like probably I didn't talk about like the data science lifecycle. We all know that, like EDA and evaluation. I'm not gonna talk about that. Maybe one thing I can talk about is how I created my custom latitude, longitude, my custom laws, because of I needed to predict latitude and longitude, and I'll explain why. I know that predicting latitude and longitude, it might be sound stupid, but trust me, I'll explain why and how I did it. So because of predicting latitude and longitude is like predicting like the actual coordinates. That's like way too deep. But the point, what I was doing, right? My clever technique, let me not say clever, maybe it's probably dumb, but what I did was that I am saying that given a location, right, within 4 kilometers, what we do is that we're gonna get all the crimes that happened. So given this latitude, we're gonna get all of the crimes that happen that are within kilometers, right? Then we create data set from that. That's what I did. So now we train the model, we force the model to train all the crimes within 4 kilometers range. That's what I did. So that's why I it's not necessary to pre. So what the idea here is that if like you are in South Africa, right? Let's look at the map for instance. So it's like if you are here, probably like you're currently here. So where's the crime likely to occur? Like probably based on the training data set, we have seen that okay, crime tend to happen probably at the nearest shop or something like that. Then the model will be able to predict that given this, and that's why we force the model to be able to predict that given the data point. So we teach it to do that. That's why I needed to create all of those custom losses that I came up with, and all of that. But it's pretty amazing stuff in a way because they work as expected in production. uh, okay, that's that. So I think, yeah, like I said, that data visioning is something way too model visioning is something quite important, and I personally did not invest a lot of time in this project building this. Probably I should have, but yeah, this is something that you should, because now when you store the model within your S3, it's not like S3's GitHub, right? It will know that this is your previous model, so you have to build that system yourself to do that. So yeah, that's that. So now I want to cover model saving. How do we get these models and we put them into production, and how do we scale these models so that we can serve millions of users? Before we kind of like get into that, I want to say that as a machine learning engineer, you will be required to build models, AI services with less than 10 milliseconds of latency. Because of machine learning, you have to think of it as a macro service, right? It's just a part in like the whole entire um, architecture, like right, there's still a backend that has to be integrated. So imagine if your model is taking like 500 milliseconds just to produce the results. That will be bad because now it will make the entire application to be quite slow. So it's very important to take into consideration those elements. But without wasting any time, let's look into our code that we serve these models. So the first thing that I want to get into is kind of like the workflow of how we kind of like make the deployment. So I'm dockerizing my models, like right, and I'm using a virtual machine from Digital Ocean. So I have to CC into my virtual machine on my local computer. Then I have to kind of like um, run this Docker file. So this Docker file essentially is gonna run these pipelines. As you guys know that when you push your code to GitHub, this code here, what will happen is that you don't have to push your models. You don't store your models on GitHub. So you have to store them on like S3. We spoke about that. But now the problem is how do we then get them here? So that's why we have these pipelines. So you're gonna neglect them. So you're gonna go to get ignore. You ignore the models, right? You don't push them to GitHub. But then when you build your Docker file, you're gonna get the models from cloud because like I said, we store them on S3, right? So you push them here. So these pipelines here, you can see that they get like the passwords from our environment variables, and they have to like get them. Then the models will be in like their respective folders, so everything will work as expected. So that's how we kind of like work around this model thing. um, which That's why I'm using this pipeline, YAML pipeline, because it makes things quite easy and it's easy to integrate in the CI/CD pipelines. But anyway, The second thing that I want to get into is the prediction setup. So we making the predictions. Let's say I'm predicting crime density. Um, One thing that I'm doing here that I want to raise is like storing your prediction into the database, but this can be quite expensive and can make your service to be slow. So that's why here I'm writing them, I'm doing that in the background. So I don't want to then slow the application. So that's why here you can see that these are the predictions that I made. So I also have some sort of like, I can see the prediction the app made. So this allows me to be able to see what I think we call it data distribution. So we can see the data that we're getting in production as well as the data that we have in training. So there's quite a lot of benefits in recording your predictions. So this is quite very, very important. It's like a software engineers who kind of like records their CPU, their memory usage of their backend system. So this is also something that as a machine learning engineer we have to do. So yeah, it's quite important. So another thing that I want to raise about is actually making the prediction in a separate thread. So because of I'm using asynchronous code here, so I want to make the prediction in like a separate thread. This is probably because sometimes the model dot predict function it might not be thread safe. So I'll share the link with you guys on GitHub. I think some of the folks also raised this issue. I don't know what was their workaround, but this is my workaround is to kind of like avoid this my model getting corrupted because of like you have this thread safety problem. So I just like make sure that I run it in like a separate thread. So this is much more safer. So this is my workaround. But yeah, this is my models. Then like I said, I have these data models that I have here, which is so I think I should rename this because I have like machine learning models, then I have like database models. Like it can be confusing. But anyway, this is like my where I write my all my predictions data. So I have another important thing which is the encryption. So this is what I learned also from the entrepreneur coding channel. So you can actually because of Astra DB, essentially you it gives you a file like this is Astra Connect zip that you have to use to kind of like talk with Cassandra, the database that you're talking to. But then exposing your connection string to GitHub might not be a good idea, and you know that you need this stuff. So how can you then kind of like work around this? So one thing that we did was that we encrypt this thing, right? You can see that you get these numbers that don't mean anything, and we it's okay to send this to GitHub because no one will crack this. Like in a sense that we have hidden the secret key. Then when we get to the the Docker file, we decrypt that. Then we get an actual file like so. You see now it's like this. So we do all of this with Docker. Docker does it for us because of what it does is that it's gonna do the encryption, run the script to encrypt that and decrypt it on the server side, right? So yeah, this is the we do it with the pipelines also as well. So this pipeline thing is quite a very important thing to do. I wanted to get into like the Kubernetes and other stuff and how virtual machine work and like Linuxes, but because of time, I see that this thing is taking a while. So because I haven't covered the back end, so I thought I would do this in like less than 30 minutes, but I see that I'm just like I'm just taking quite some time. So here I'm using the Docker Compose to make some of my predictions. Also here I'm using Docker, but then I wrote some of the Kubernetes stuff. I'm using Node.js and the Express library to do my backend. So whereby Imagine I have the controllers, I have models like, and I have like the user sessions. So I'm using JWT to register, login the users. So this is pretty much your backend stuff, and it's type safe, all of the stuff inside here. So yeah, this is my backend saviors. uh, I'm sorry that I did not actually cover this in much more detail, because like I said I will, but because of the time, probably I'll make a separate video and continue to cover this stuff. And probably maybe I'll actually open source this code. So this is my Flutter stuff. Like I said, that I'm not a mobile developer. If I'll give you advice here, I'll probably leading you to a wrong direction. But there's a GetX stuff that we build as our state management, which is much more powerful. Um, so yeah, this is pretty much what we also have here. We have this. With all of the models, controllers also. One thing that I really admire is having these models. So we have these predictions. So you can have these models that you create on Flutter. Then when you make a request, you know that the data that you're getting is quite good. So it's something that we do with Flutter stuff. So quite impressive. But yeah, that's all. And this is the final app, and like the whole entire app leads to this application here. So yeah, thank you guys for tuning in. I really appreciate it. I know that I didn't cover like the cloud stuff, whereby we can use Kubernetes and Docker and all of the stuff. This is purely because of time, but I will probably create a second half video so that I can walk you guys through it. But without wasting your time, thank you for watching. I'll see you in the next one.